Good morning to all. In the previous sessions, we completed 2 units. These 2 units are of fundamental concepts. That's why they have taken much time, duration. Now, from 3rd unit onwards, we are going for the applications on the basis of the first 2 units. So here we can make a little bit faster this one. So now today we are going to start 3rd unit in signal systems. Let us start. Now just we are going to start with unit 3. This unit 3 contains Fourier. This unit contains Fourier integral plus Fourier transformations plus Laplace transformations. So now, before starting for the 3rd unit, student has to remember all these things. Now look at this 3rd unit. We have to begin with Fourier integral. Now just look at this is Fourier integral. From this Fourier integral concept, we are going to study Fourier transforms or transformations. Similarly, here we are going to start with Laplace transforms. Now just look at this binary structure of this one. This is unit 3. In the unit 3, the main part is Fourier integral. Under this integral, it has 2 more children, but as per our syllabus is concerned, we are focusing only on Fourier transforms and Laplace transforms. So for Fourier transforms and Laplace transforms, the base mother is Fourier integral. Now come back. In the 2nd unit, what we studied in the 2nd unit? Fourier series. We studied Fourier series in 2nd unit. In 2nd unit, now here we discuss Dirichlet's condition. After that, we discuss Dirichlet's theorem. Dirichlet's theorem. Now just look at, for discussing Fourier transforms and Laplace transforms, root node is not root node, main node is Fourier integral. To discuss Fourier integral, the root node is Fourier series. That's why in the 2nd unit, Fourier series chapter was given. After that only, we are going to study Fourier integral. Students have to remember the connectivity or dependency between Fourier series and Fourier integral. Without Fourier series, there is no question of Fourier integral. Without Fourier integral, there is no question of transformations or transforms. There are many kind of transforms, but in the syllabus is concerned, we are concentrating mainly on Fourier transforms and Laplace transforms only. Okay, this is the concept. Now, first let us discuss what is Dirichlet's condition. Now, just look at what is Dirichlet's condition. Actually, this condition was given by French mathematician Dirichlet. On his name, just we are discussing this, Dirichlet's condition. For example, look at, this is a 2 marks question, repeating question. 2 marks for most of the cases, they are asking for 2 marks. Some cases, it may be for 3 marks also. What is Dirichlet's condition? Now just look at, don't by heart the concept. Let f of x be a function, or you can write x of t, a signal. Let f of x be a function defined in the interval minus pi to pi. Now just look at, the interval is a closed interval. Closed interval in the sense endpoint should also be considering for the interval calculations, period. Now let f of x is defined in minus pi to pi. Let f of x be a periodic function. Let f of x be a periodic function. Why this condition? Once it is periodic function, then only we can express f of x, the given function, in terms of what? Fourier series. To express any function in Fourier series, we have to create a periodicity for the signal or function. So now let's look at Dirichlet's condition. Let f of x be a function or a signal defined in minus pi to pi closed interval. Let f of x be a periodic function. Then we can express f of x in terms of Fourier series. Let f of x has a finite number of maxima and minima in the given period. Let f of x has a finite number of discontinuities in which one? Discontinuities in minus pi to pi. If the function satisfies this condition, if it satisfies all the this condition, then f of x converges to, look at this point, f of x converges to half f of minus pi plus 0 plus f of pi minus 0. This is called Dirichlet's condition. Here one important point. Converges means what? All inputs, what are the inputs you give, all are focusing at one point and give always only one output corresponding to that input. That is called convergence. You already done this convergence, divergence formulas and concepts in M1 paper in BTech first year. There you get converges. So converges to which one? F of minus plus 0 and a pi of minus 0. Here students, advising to students is that minus pi plus 0 is equal to minus pi, pi minus 0 is equal to pi, not like that. This is called right hand limit. This is called right hand limit. This is called left hand limit. So right hand limit plus left hand limit, half of the value. This is called Dirichlet's condition. So before entering into this, the concept of Fourier integral, we have to begin our discussions with the first concept, that is called Dirichlet's condition. So again I am repeating, let f of x be a function or signal. That f of x be is defined in a closed interval minus pi to pi, and also then we can, once it is defined in the closed interval, now we can express the given function f of x in terms of Fourier series. Now let us assume that f of x has a finite number of maxima and minima, ups and downs, a finite number of maxima and minima, and also let f of x has a finite number of discontinuities in the given interval minus pi to pi. If any function satisfies all these conditions properly, then the function converges to means what? Gives only one single exact value, that is f of minus pi plus 0 and f of pi plus 0. Here minus pi plus 0 is called right hand limit, that is called left hand limit. This is called Dirichlet's condition. Okay, this is called Dirichlet's condition. Now just look at. Now a function or signal f of x is satisfying if f of x is expressed in terms of Fourier series it is expressed in terms of Fourier series plus satisfying Dirichlet's condition. Now just look at a function f of x. So if f of x can be expressed in terms of Fourier series and it also satisfied the condition of Dirichlet's condition, then only we can talk of Fourier integral. This concept is very much important. Students have to understand properly. Again, I am repeating that you take any function or signal f of t or x of t. That function should be expressed in terms of Fourier series and that function should also satisfy the condition of Dirichlet. If these two are satisfied, then only a function f of x or a signal x of t, both are same, x of t, they can be expressed in terms of Fourier integral. This is one of fundamental concept of this entire third unit. So students, again I am repeating this same important point for your understanding purpose. Fourier series is for any function or signal f of x. Any function or signal, Fourier series are needed, and also Dirichlet's condition is also needed to give the output of Fourier integral. Fourier integral. This is very important concept students have to understand. Now we already started the introduction to Fourier integral. Now as long as we talk of Fourier integral, students have to understand the function can be expressed in terms of Fourier series and also satisfies Fourier integral. No need to repeat it again. Okay. Now, this is the Fourier integral. Now, once it is satisfied, now this Fourier integral concept, from this, after studying this concept, in this chapter, we are studying Fourier transforms. Here also we study Laplace transforms. Now, this entire unit consists of these three concepts: Fourier integral, Fourier transforms, and Laplace transforms. Now, we will focus on these concepts one by one. Okay? One by one. Now, in the next session, we will be begin with Fourier integral. Okay? Thank you.